Hello and welcome to this presentation. We are going to be considering composite slab design where we have to carry out modeling analysis and design. We will look at the part of the composite which we have the concrete, we have the anti-crack bars, and then we have the metal sheeting or steel deck. We also have the rebar part of the composite slab successfully. Other important part of composite slab we are going to be considering is the stud connector. These are the things we are going to be designing, and then the primary and secondary beams successfully. So we are going to be considering modeling. We load it, analyze, and as well as design successfully. Stay connected as we dive into the presentations. So here we go. At first, we are going to be creating a grid line set out for the design of the composite slab. But before that, I will be taking you to the setting provisions. So I click on the settings so you actually see the code of practice that I'm using. So over here, the code I'm using is the Euro code. Okay, so I'm using Euro code for this design successfully. Okay, so after which I click on the OK option. I want to be creating a grid line set out. So I will navigate to the modeling tab, click on the orthogonal axis generator. I pick any point to have the dialog just like this. I'll be having 4 meters in this direction, and then I'll be having 3,500 in these directions, just like this. Okay, so this is going to be my grid line set out for this composite slab design. I click on the OK option, and I have the grid line set out just like this. So this consists of 9 panels we are going to be designing for the composite slab successfully. You have to take note of the default height of this floor is 3 meters. So we are going to be working with this successfully. After which we will now start to place our steel column. So I come to this function where I have column. These options I click once, and I have the column dialog right here. I can use the property or section manager to actually change the sections of this column if I am not okay with the default section. I'm taking it to this particular sections successfully. I click on the OK or select an OK options to have it in place. So I want to be inserting this column at the grid line intersection point. So I will pick on these provisions and do a window over all of the grid line intersections. I release my hand to have the column placed successfully, just like this, after which I closed this dialog. Now we are going to be modeling the composite beams. I want to be explaining something very important here, because modeling a composite beam is different from modeling an ordinary beam. Okay, ordinary steel beam. So if I come to the modeling tab right here, I'll first of all save this project. I click on save options to have this project saved successfully. And then over here where I have frame, this is where we have all the beams. I select in the drop down arrow to have a drop down menu just like this. You can see over here we have the primary composite beam, you have the secondary composite beam successfully. Okay, so these are the 2 beams you are going to be working with while designing the composite floor successfully. You have to make sure you use these 2 beams. You can actually use the first one and later convert it to this one, but it must be these 2 for that floor to actually carry out analysis successfully. So let's start. We want to start with the primary composite beam. I select it right there, and then I can change my sections from these provisions. I will be using the same sections just like this, and then I may go by these second options for the web and as well as the thickness. I select that and OK, after which the directions of my primary beams is going to be in the horizontal directions. So I will pick grid line intersection D1 and then all the way to D4. I place that. I want to split it, so I will click on the yes options to have it split successfully, just like this. And then I will also be having a grid line in these provisions. Just like this, I will also split that. I can as well do a window just like this over the green line intersections and over the columns point. Release my hand, but this will actually create it even along the longitudinal or the vertical axis, but I want it within the x-axis, which is along the line D. So I'll place it just like this, and then this one just like this. All right, so this is my primary beam. The next beam I'm going to be placing is going to be a secondary beam. Okay, so I can come to these provisions and then I select these options. Secondary composite beam. I can decide to close this dialog and then select on the frame. In the drop down menu, I choose the secondary composite beam, just like this, and after which I will start to place this successfully. And then I can decide to use the frame option to place it. Okay, if I close this now, I will click on this frame. In the drop down menu, you can see frame groups. Okay, I want to use these options. I click right there, and then I have this successfully. Now my spacing is going to be 1 meter, okay, between the secondary beams, and then the quantity is going to be 4 within a space provisions. All right, like within a panel. All right, it's going to be 6 within a panel plus the H beams successfully. Okay, so I can use this provision to control the number. If I want it to be 4, I can key 4 right here, and then I will have it 4, and then the space is still 1 meters. Okay, so I can click in these provisions and be able to edit the space as well. So let me go by the 6 number just like this. Another setting you have to do is to select the generation options. Okay, you can see if I select in these provisions, I can see remove first and last member, delete first member, delete last member, normal. If I use normal now, I have to select the first member, the second member to have it been placed successfully. I'll do that in this panel to have it placed here successfully as well. While placing here, since I have both the edge beams right here, I don't need to use normal options again. What I need is to select in these provisions as said, remove first and last member. So if I pick this first and then pick the second beam, I'll have this placed while the edge beam is not placed successfully. Okay, so now I proceed. I will do that in these provisions. I will as well do that in these provisions. So that the next option I'll be using is going to be normal. All right. So I pick this first beam and then I pick the second beam to have that placed successfully, first and second, to have it placed just like this. Okay. This is how it works when it comes to composite slab design. You must use this pattern. All right, it's very, very important. So now I'm done modeling my beams, my composite beams. So I want to start to actually model the composite slab that will consist of the metal sheet and then the concrete itself. All right. So for me to do that, let's navigate to the 3D to actually see what we have done right here. I will come to this provisions, navigate to 3D, and then this is my formations, okay, at the first floor. All right, so I want to place my slab right on it. So I'll come to this provision where I have composite slab right here, this provision. So if you select in this drop down menu, you can actually see the first instructions options and the second instruction options. I want to be doing this instruction at the plan view, so I'll navigate to the plan view of this story. So I'll select on this, pick the first point. Now, before I place my slab, I'll be alerted to set my loading combinations. Click on yes options to open the load combinations editor dialog. This one. Click on the load the generator. I want to get rid of this pattern load automatically. I'll be using this one, the life and dead load, and then I will create different combinations for steel member design successfully. After which I'll click on the OK options to have my load generated. I OK again. That is my combination successfully. Now I can now place the composite slab successfully. So I pick the first point, move my hand to the adjacent point, and then I click right there. So this will open a composite slab window, this window. All right. So in this window, we have the label. All right. We have the slab type. Above the flange, we have level to primary beam flange. I will explain this to us. The material as well, the grade of the anti-crack bars, and as well as the deck type, which is the metal sheeting. Here you can be able to actually select any type of metal sheeting. I can hold down the right button of the mouse, move my hand to object it this way. I zoom closely, so you can now see the difference between my composite primary and secondary beam successfully. So now this is the first options, first type of slab. Okay, this is the second type of slab. So as the first type of slab, you can see that it is only the secondary beam that is a composite beam right here. So the primary beam is just like a support beam, okay, to the secondary beam successfully. So if you use these options, you will notice that the slab itself will be resting on both secondary and primary beams successfully. So you can either design using this method, or you can as well design using this other method. So if you select that, you see what you're having. Okay, so the slab is actually being carried by both secondary and primary beam. So for this reason, you call both composite beam successfully. All right, so we make progress after we must have selected these options. The next thing I want you to take notice of is the direction of the metal sheet, okay, which is the steel deck. You can see the steel deck directions is actually transverse to the directions of the secondary beam successfully. Is transverse. So this is the right way it's supposed to be. So in case we are designing and this is not transverse to the directions of the secondary beam, you have to change it using these provisions. Here, if you turn it 90 degrees, it's going to change. You can see it changing here. I'll turn it back to 0 degree, see it. Okay, so if it is not in that direction, your slab is not going to design. All right, the next thing you will look at is the concrete strength, which is the material. If you select in these provisions, you can be able to select any of the material right here, which is going to give you your mix ratio that you are going to be using, okay, while construction successfully. We'll go by this default 25/30 successfully. I click on the OK options. All right, now coming over to the provision, you have the grade 485 A fabric. All right, we go by these options, and then deck type. If you select in this provision, see various type of deck. If you select here, you can see, and you can make changes as well in these provisions. Okay, I will use the first deck type, and then click on the OK options. All right, so having done that successfully, we proceed to the slab thickness. All right, so once I change the slab thickness here, the safe weight is going to change here accordingly. So I will use slab thickness 120 millimeters successfully. So I can decide to use 150, okay, right here. And then live load construction stage. So at the construction stage, there will be a lot of activity going on here, humans activity right here. So we have to provide a live load, okay, right here. Make it 0.02, just like this. So we have dead loads, okay. So this is just like a dead load based on the purpose of the structure. All right, so if you select in these provisions, you have its room. You can see trans, balcony, and lower slab successfully. We use the first option for room, okay. Let's say for instance the design is a residential structure. We also have live load composite stage. So this live load is for the purpose of the structure. It is a residential, it is a commercial, okay. So we use general domestic used options successfully. Other loadings you see here are the roof live load, snow load, rain load successfully. So you can apply this depending on where you want to actually place this composite slab successfully. All right, so now we are done with our loadings on this slab, okay. So if you come over here, you can actually see the beams sections right there, which you can still change it from here if you're not okay with these sections. Just as I've clicked, and then this frame member still dialog comes up, okay. I will just have to click on the OK options. So that is it at the section successfully. Okay, see, we have the primary as well as the secondary frame effective width right here. All right. So now we are done with loading this floor. We are going to click on the OK options here, and then to have the floor placed successfully. I right click or I escape to get rid of the command. So this is the meta sheet. Okay, it is transverse to the directions of the secondary beam. Take note, it is very, very important while designing a composite floor in the Protastructure. All right, so at this point, I'll navigate to the 3D, and then let's see our floor in 3D just like this. So if you want to make a multi-story of this, you can just create more story, and then you generate your story successfully before you carry out your analysis. Okay, at this point, we want to proceed to the analysis, but by then you have to save this project. All right, so I will navigate to the analysis tab right here, and then I'll click on the building analysis. All right, so I will click on the building analysis. We will navigate to the analysis tab, and then we have to check if our model is okay. Click on the building model check, and then start the check. All right, so number of errors is 0. We don't have any error in this model. Click on the OK options and then do the analysis options. So we wouldn't design any structural elements right there. We'll do that later. Click on the building analysis. So we are going to observe to actually see if there will be any analytical error that will result from this model. So let's observe it together as we make progress. And if you have any question, drop it in the comment section successfully. Or you can join our group chats. There's a link in the description of this video. Okay, so analysis is successful. You can see we have a related story draft. Satisfies limit in both directions successfully. All right, you can see. Meaning our model is very okay. Click on the OK options right away. And then we click on the closed. At this point, we want to start to design the composite beams successfully, as well as the stud connector. So we will be able to design the composite beam as well as the stud connector successfully. Stay tuned and let us move into that. And then I want to let you know, if you check here, once you run a building analysis on the composite floor, you can see FE analysis has been run successfully. So if you don't have this FE analysis runs, you may not be able to design this successfully. Okay, and this you are not going to do separately, but you are going to do it successfully while you are carrying out your major or the static analysis. The finite element flow analysis will also be carried out alongside successfully. Take note. All right, we proceed to the design of this. So we'll go to the design tab right there, and then over to these options, we have composite beam right here. Click on this composite beam to actually have the composite beam design options dialog. Okay, so in this dialog, we can decide to select any of these beam and use these options to check it one by one. Check selected. All right. Apart from that, we can decide to check all at once. I like checking all at once. I click on check all. So you can see, very unfortunate that none of our beam has passed design. You can see all failed. You can see. All right. So now, not everything that consists of this composite slab design that actually failed. There are some things that failed here. So I want to be pointing out those things that failed, but you have to check and to know what actually failed. So double click on one of the beam. As I double click right now, a dialog has come up. You can see that the stud has been designed successfully. Mind you, stud on all the beam cannot be the same. Some of the composite primary and secondary beam may be having stud so much like a number than what we see right here. He designed the stud for you successfully at 8 positions. So let's see what is failing. Composite longitudinal shear resistance is failing. Okay, shear resistance has to do with the shear reinforcement, which are the anti-crash bars. So this failure simply means that the anti-crash bars sections, like the diameter, is not enough. All right, so if you come to the reports right here, you will see that you have a lot of reports over here. Longitudinal shear resistance error sections is not sufficient, just as I said earlier. Okay, if I scroll down, you also see the result right here. Okay, so these are the report that you are supposed to print alongside with the composite beam successfully. Okay, so there are a lot of reports here. So here is where we have the failure. Okay, this check has failed successfully. I want to show you how to correct this failure. So stay connected. I'll get back to the provisions. And also, if you want to rearrange it, you want to rearrange the stored, you can use the segment provisions to rearrange the stored, and then you can also use these double provisions if you want it to be double. Okay, you can actually set that up successfully. So you can use uniform, and then you can have two at the both edge, and then you can use single options. You can see stored per row. All right, so these designs are actually passed successfully. But let's correct this failure with scenes. If any of these fail while all has passed, the whole composite beam will be actually failed successfully, just as we have seen over there. If I click on the OK options, you can see all of it right here is failing, but it's only one option that was actually failing. Okay, while other options has passed. Okay, I click on the close options. Let's correct that. Okay. So for us to be able to correct that, you have to click on the composite slab, double click on it to have the dialog successfully, just like this. Okay, so I will go straight away to where I have grade 485, A fabric. Okay, I'll click in that provisions. I need to change this, okay, to this D fabric, okay, this fabric. Or I can use this grade 500 A fabric, okay. This is higher in diameters as compared to the first one, okay. So after we click on the OK options, and then in these provisions, I can select here and then use A6 options. So this is the changes I needed to do right here. After we click on the OK options, this is going to nullify the analysis I've done so far. Click on the yes options, which means we have to carry out analysis again on this structure. Then we navigate to the analysis tab right there, and then you can see that the building analysis, both the FE is now check red crossed, meaning it has been nullified successfully. I click on this building analysis, but by day we have to save this project. All right, click on the save right here to have the project saved. Then click on building analysis, go to the analysis. We don't need to check again because we have checked before. Click on building analysis again. All right, so in this provisions, building analysis again. So this is going to run through and actually carry out the analysis so we can proceed into design. Let's see if we have actually corrected that failure successfully. So analysis is done successfully. Click on the OK options, and then I proceed. It said FE flow analysis and building analysis have been completed for constructions of a composite floor successfully. You can see right here. Click on the close options to get rid of this dialog, and then I will navigate to the design tab, and then I go to composite beams. So in this, I want to be designing all at once. Okay, I click on check all options. Good. So you can see all has been checked successfully. You can see we have the status of our design passed all through successfully. Now you can see the stored layout right here. You can see on this beam 1F1, 1F2, you can see the stored layout, the total number of stored differs right here. So if I select these beams, now you can see on this I have 8 stored. I double click right here, you can see I have 8 stored design successfully. Okay, everything here has passed. You can use these provisions to print your report successfully. Just like this, you can see right here. Click on the OK options right here. And then if you check other stores, some are 4, some are 3, depending on the beam. So this information is very, very important. You have to take note of the member labels and then be able to assign the number of stores successfully, so you can be able to actually connect the metal sheet successfully on top of the composite primary and as well as secondary beams successfully. All right, so this is how this design is being carried out. Okay, I click on the OK options. So design is done. The next thing we need to do is the reinforced concrete part of the design we are going to be looking at using the FE floor options, okay, which we will be looking at that in the next presentations. Okay, so we are going to stop here. So stay tuned. Don't forget to like. Don't forget to subscribe to this channel, Soft Reason. If you have any question, drop it in the comment sections. There's a link in the description of this video where you join our group chat. And as well, you can see most of our materials, okay? And then you can be able to get them to assist you in your design office successfully. We'll see you in the next presentation. Stay safe and bye for now.